Hello everyone, welcome to my channel Chemistry by Miss Nidhi Banga. Today we'll be talking about all 10 reactions of carbon and its compounds. So there are 10 reactions, no more, no less, in the chapter carbon and its compounds, and we will be talking about all of those one by one in detail. We'll be talking about how to remember the products and special things about those reactions, how to remember their names. We would also be talking about different activities related to them. All activities would be covered in this video. Okay, so these are the reactions which we'll be taking up. Combustion, oxidation, addition of hydrogenation, addition of hydrogen, so it's also termed as hydrogenation. Substitution, reaction of alcohol with sodium, reaction of alcohol with concentrated sulfuric acid. Esterification, saponification, reaction of carboxylic acid with base, which is basically neutralization, and reaction of carboxylic acid with carbonates and hydrogen carbonates. So let's get started. Okay, now let's talk about the first kind of reaction, combustion. Combustion is essentially reaction of any combustible substance with oxygen. This is reaction with oxygen. Okay. Now, the second thing that you must remember about combustion is that it's highly exothermic. Exo means out, therm means heat, which is a form of energy. So exothermic is any kind of reaction which liberates energy, which gives out energy. Could be in the form of heat, could be in form of light also, right? So this reaction, combustion reaction, is always highly exothermic. Okay, now let's talk about the kind of products that are formed. Now, when it's just carbon, like carbon in its all its allotropic forms, such as graphite or diamond or Buckminster fullerene, when they are combusted in presence of oxygen, the only product that is possible is carbon dioxide, right? Nothing else is possible. There's no other element here. When we talk about carbon compounds such as methane, ethane, propane, butane, or any other hydrocarbon which has carbon and hydrogen, when that is combusted in presence of oxygen, there are two products possible. First, when carbon reacts with oxygen to give carbon dioxide, and then when hydrogen reacts with oxygen to give water. Needless to say, they always liberate heat and light. Heat and light. Okay. Now here, alcohol, it has carbon, hydrogen and oxygen. Regardless of that, there would be only two products, carbon dioxide and water, and again heat and light. Now, these two reactions, the last two reactions, are not balanced. So let's balance it. One carbon, no need to touch it. 4 hydrogen, 2 hydrogen. Let's put a 2 here. Now it's 4 hydrogen. Here we have 2 oxygens. Here we have 2 plus 2, 4 oxygens. So let's put a 2 here, and now it's balanced. Talking about the third reaction, let's see if that is balanced. It's not, simply because there are 2 carbons here, 1 carbon here. Let's make it 2. Hydrogens, 5 plus 1, 6. Here we have 2. Let's put a 3 here to make it 6. Oxygens, here we have 4 plus 3, 7. Here we have 2 and 1. So if we put a 3 here, that would make it 7 also, because 3 times 2, 6 and 1, 7. Now it's balanced. Okay, this is the simplest thing that can be asked from this chapter, from this topic, combustion reaction. Now, not so simple thing and very commonly asked thing is sooty flame and clean blue flame. Now, what happens is all your unsaturated carbon compounds, when they are burnt, that means when you introduce them to a flame, there's oxygen in the air. When they are burnt, they burn with a yellow flame. And there are sooty deposits. Now, what is that? Okay, so the products that we discussed here are the products when there's a complete combustion taking place. Okay, but that would not be the case if we have unsaturated carbon compounds. Unsaturated carbon compounds are the ones which have carbon-carbon double bond or carbon-carbon triple bond. Okay, these are unsaturated compounds and they have relatively high carbon content. That means they have high percentage of carbon. Why is that? Okay, let's compare here ethane and ethyne. Okay, this is saturated, these two are unsaturated, and we can clearly see that the hydrogens are fewer in case of alkenes and alkynes. Fewer hydrogen means less percentage of hydrogen. Less percentage of hydrogen means high percentage of carbon. That is why we say that they have high carbon percentage or content. So what's the problem if they have high carbon content? If they have high carbon content, all of it does not get completely combusted. There would always be some carbon which will be left unburnt, and that carbon is the soot. So that is why you get sooty flame. Okay, so unsaturated carbon compounds give sooty deposits or sooty flame. The flame is yellow, or you also call it luminous flame. Now, when you have saturated carbon compounds, they are saturated with hydrogens. That means they have enough amount of hydrogen, high percentage of hydrogen, therefore comparatively low percentage of carbon. Low percentage of carbon means all of it will get completely combusted and converted into carbon dioxide. No sooty deposits. So it will burn with clean blue flame, and it's also called as non-sooty flame. Alright. Now, the thing where students get confused sometimes is this. Okay, let's talk about activity 4.3 and we will see where the students get confused. So activity 4.3 says that you have taken some substances, these three substances, naphthalene, camphor and alcohol, in spatula, and you have introduced them into flame. So which one will burn with sooty flame and which one will burn with clean blue flame? Now, naphthalene is unsaturated compound. Why? Because it's basically benzene. Two rings of benzene fused together. Okay, benzene is unsaturated, therefore naphthalene is unsaturated. If it's unsaturated, it's going to burn with sooty flame. Okay, camphor is also unsaturated. No need to know the formula, just know that it's unsaturated. If it's unsaturated, then this also will burn with sooty flame. Alcohol, as long as it's a saturated alcohol, that means no double bonds in the alcohol, it's going to burn with clean blue flame. Now, acetic acid, CH3, C double bond O, OH. The thing where students get confused is they think that any double bond means unsaturation, but that's not true. Carbon double bond oxygen does not mean unsaturation. Unsaturation is presence of double bonds between two carbon atoms or presence of triple bond between two carbon atoms. That means carbon-carbon double bond or carbon-carbon triple bond. Only this is unsaturation. This is not unsaturation. And since it's not unsaturation, it's going to burn with a clean blue flame. Okay, so this was combustion. Now we will talk about oxidation. Okay, before we get any further with oxidation, let's talk about activity 4.4. In activity 4.4, basically they talk about Bunsen burner. Now this is the diagram of Bunsen burner. It has a hole. This is the hose through which basically the fuel goes in. This is the hole which allows air to get inside. And there's a thing here. There's a thing which can completely cover the air hole, and it's called as a collar. Now, if you rotate the collar in such a way that the air hole is closed, then there is no supply of air, right? In that case, complete combustion will not take place simply because there is insufficient amount of oxygen. Okay, in that case, the flame that you get would be yellow flame. Okay, yellow flame if the air hole is closed. Okay, clear blue flame, clean blue flame if the air hole is open. Okay, you experience similar situation when you are using a burner at your house, the gas burner, the regular gas burner at your house. Sometimes you would see that the cooking vessel gets blackened from the bottom. Now, why is that? If that happens, that means there are the holes that are there in the burner, they are choked. If they are choked, basically the air is not able to get in. And if that happens, definitely there is insufficient supply of oxygen, and therefore complete combustion doesn't take place. That means some of the carbon remains unburnt, which is the soot, which blackens the bottom of the cooking vessel. Alright, now let's talk about oxidation. Oxidation, as you also must have studied in redox reactions, oxidation is removal of hydrogen or addition of oxygen. Okay, so if you have alcohol like ethanol, and if you treat it with alkaline KMnO4, that is potassium permanganate, or acidified K2Cr2O7, potassium dichromate. I'm afraid you have to remember the names and the formulas of these two. Okay, either one of those, not both. When you treat alcohol with either one of those, it would be converted into acid. Okay, this is acetic acid or ethanoic acid. Now, how is that oxidation? As you can see, number of carbon atoms same, 2, 2. number of hydrogen atoms, there's a removal of these two hydrogens. And in place of these two hydrogens, carbon is doubly bonded to oxygen. So there's a removal of hydrogen and addition of oxygen both. So this is definitely oxidation. And these two things which are bringing about this change, they are called as oxidizing agents. Okay. Now, let's talk about activity 4.5. Now, activity 4.5 says that you have ethanol in one of the test tubes. Okay. And you are dropping KMnO4 drop by drop into it. KMnO4 is purple in color. Okay, dark purple in color. If you have an aqueous solution of KMnO4 and you've added a little bit of base in it so that it's alkaline in nature, that if you put in or add in drop by drop, the color of KMnO4 would disappear. That means it would become colorless. Okay, the color of KMnO4 would disappear. But why does that happen? That happens because KMnO4 is getting consumed in bringing about this change. If KMnO4, which is purple in color, if that's get consumed in a reaction, obviously the color would also go, because color of KMnO4 was because KMnO4, right? What happens if you add excess of it? Now you've added KMnO4 drop by drop and the color discharges, but if you keep on adding, the color would persist. Would persist. Why is that? Because now all of the alcohol has been converted into acid. All of the alcohol has been converted into acid by using KMnO4. Now if you keep on adding more KMnO4, it's not getting consumed. Okay, because there is no alcohol to react with KMnO4. So KMnO4 remains unused and therefore it shows its color. Okay, so addition of excess of KMnO4, the color of KMnO4 would persist in that case. Time for our next reaction, hydrogenation. Okay, let's now talk about addition reaction, which is also called as hydrogenation reaction, especially when the thing that is being added is hydrogen. Now, main thing about addition reaction is that it can only occur if you have unsaturated hydrocarbons. Okay, because saturated hydrocarbons, like the name suggests, they are already saturated with hydrogens. That means no more hydrogens can be added, right? Unsaturated, they're not saturated with hydrogens. That means there is still some scope to add hydrogens. And that is what happens here. Okay, unsaturated hydrocarbons, addition of hydrogen happens there across the double bond or triple bond. Or you can say it happens at the expense of double or triple bond. That means these bonds have to go. Okay, now let's take this for example. This is the reactant given in your book. Don't worry, R is nothing strange. R can be any alkyl group. We call it alkyl group. Okay, why alkyl group? Because it is derived from alkane. Alkane minus 1 hydrogen is alkyl. So if you have methane, CH4, minus 1 hydrogen, that is CH3, is methyl. Here you have methyl. You have ethane, CH3, CH3, minus 1 hydrogen, that is CH3CH2. This is ethyl. Okay, so R group denotes any alkyl group. Okay, now whenever there is hydrogen which is being added to an unsaturated hydrocarbon in presence of nickel and palladium, nickel or palladium, they are catalyst. Their job is to just speed up the reaction. Okay, it's only hydrogen which is being added here. Nickel or palladium are not seen anywhere in the products. They are just catalyst. Okay, so what happens is this hydrogen has two hydrogen atoms. They will get added across the double bond. That means one hydrogen would get added here, the other hydrogen atom would get added here, and one of the two bonds have to go. Okay, so the product would be this is something that you had already, but now hydrogen atoms are added across the double bond at the expense of double bond. Double bond has to go because carbon can make at most 4 bonds. Here 1, 2, 3, 4. Now if hydrogen has to be added here, carbon cannot make 5 bonds. Something has to go, and it's one of the bonds from the double bond which will go here. Okay, so this is your product. Now if you have any other compound which has a double bond, you can write it in this way. Then add hydrogen across the double bond at the expense of double bond. Okay, so your product would be CH3 carbon, CH2 CH3. Here we have again CH2 CH3, that is ethyl group. Here again we have methyl group, and now hydrogen can be added where double bond was. Okay, so this is your product. All right. Okay, now what's the relevance of addition reaction? Relevance of addition reaction, especially when it's hydrogen, is that vegetable oils can be converted into solid fats by hydrogenation. How? Vegetable oils are basically unsaturated fatty acids. That means they have carbon-carbon double bond. Okay, there are many carbon-carbon double bonds here. And they are liquid. Oils are liquid. Okay, like your soybean oil or your palm oil, right? Animal fats, on the other hand, are the ones which are derived from animals, such as your desi ghee. Now this is saturated. Okay, they are saturated fatty acids. Now the difference between desi ghee, which is an animal fat and saturated fatty acid, and dalda ghee, dalda or vanaspati ghee, or margarine, is that they are basically vegetable oils solidified by addition of hydrogen in presence of palladium or nickel. Okay, so their origin is not animal, their origin is plants. They are plant-based fats, but definitely they are saturated because they have been made saturated by addition of hydrogen across the double bond or triple bond. All right, so vegetable oils, unsaturated fatty acids, dalda, vanaspati ghee, margarine, and desi ghee, they are saturated fatty acids. But the difference between desi ghee And these three is that the origin is different. The origin here is plant based and this is animal based. Now this, if you remember, this is also one of the uses of hydrogen which you learned when you were doing chloralkali process. One of the products in chloralkali process is hydrogen, right? So uses of hydrogen was production of margarine. Now you know what margarine is. Okay. Another kind of question which is very commonly asked is this. Now, when you have double bond and addition of hydrogen takes place in presence of a catalyst, you know that hydrogen gets added at the expense of double bond. I can write it like this. Okay, so from ethane has been produced by addition of hydrogen. Okay, and now since if you see the difference in the number of hydrogens, here the number of hydrogen is 4, here it's 6. So the difference is 2, which is made up by hydrogen here. Now, if you talk about alkynes, they have even fewer number of hydrogens. Okay, when you add hydrogen in presence of a catalyst across the triple bond in alkyne, what happens is only one bond of the 3 bonds in triple bond will go, double bond would remain, and you would get an ethene if you add only 1 mole of hydrogen. But if you add another mole of hydrogen in presence of palladium, then this hydrogen gets added across the double bond at the expense of double bond. So now you get ethane. So if I have to write this reaction in a nutshell, I would say that for ethane, you require 2 moles of hydrogen to form ethane, right? So if you were to convert ethyne to ethane, remember that you have to add 2 moles of hydrogen because you have to get rid of 2 bonds out of the 3 bonds between the 2 carbons. Okay, that would require 2 moles of hydrogen or 4 hydrogens. Okay, so this is one of the very common questions which is asked. Our next topic would be substitution. Okay, now let's talk about substitution. Substitution, as the name suggests, one atom is being substituted in place of the other atom. Okay, so there's a simple exchange of atoms. Now, substitution happens when there is saturated hydrocarbons such as methane, ethane, propane. When they are treated with chlorine in presence of sunlight. Now this is very important. Without sunlight, or sometimes UV would be written. Okay, UV light or sunlight. Without these things, the reaction would not occur. Okay, so this is very important. If you don't mention that, you would lose points. So when methane, the saturated hydrocarbon here, combines with chlorine in presence of sunlight or UV light, what happens is one of the chlorine gets substituted with one of the hydrogen, right? So one of the hydrogen is replaced with one of the chlorine. So what are you left with? Hydrogen from methane and one of the chlorine atoms from chlorine. They would combine and form HCl. The interesting thing is that the reaction usually doesn't stop here. If you allow it to happen, the reaction will go on in presence of sunlight. It would form now CH2Cl2. Again, a substitution takes place. One hydrogen is removed and a chlorine is added. And again, you get HCl as a byproduct. The reaction doesn't still stop. This is CHCl3, commonly known as chloroform. Chloroform can make you faint. Okay, it was earlier, it was used as a local anesthesia. Okay, again, if you add chlorine in presence of sunlight, the reaction would give you carbon tetrachloride or tetrachloromethane. Okay, so when methane is combined with chlorine in presence of sunlight or UV light, you get chloromethane. But if you allow the reaction to proceed, the reaction keeps on going until you get tetrachloromethane. Let's review the name: chloromethane, dichloromethane, trichloromethane, tetrachloromethane. Okay, that's all you have to know from in substitution. Okay, let's talk about reactions of ethanol. The first reaction is with sodium metal. So there's ethanol. When it's reacted with, when it's combined with sodium metal, the product that you get is this, along with hydrogen gas. Okay, so basically what has happened here, there's a simple exchange between sodium atom and hydrogen atom. Okay, but since hydrogen gas is released, that means hydrogen as a molecule has released. So if you have to balance the reaction, this is how you balance it. Okay, now if you remember the reaction that when metal combines with acid, it gives a salt. Salt means ionic compound, and hydrogen. If you compare this general reaction and this reaction, you would see that this is salt, this is hydrogen gas, this is metal, so this has to be acid, right? So this reaction basically proves the acidic nature of alcohols. Okay, so all alcohols upon reaction with metal, they give salt and liberate hydrogen gas. Now, if you were to test the gas that is released, how would you do it? You just bring a lit match close to the mouth of the test tube and you would hear a pop sound. Simply because hydrogen is a fuel, right? So there would be a tiny blast which will make the sound pop. Okay, so this was your activity 4.6. where you added a small piece of sodium in ethanol which was taken in a test tube, and you see the release, you see the bubbles released, and when you bring a lit matchstick close to the mouth of the test tube, you hear pop sound, which proves that hydrogen gas was released. That means alcohol must have some acidic character. Okay, now naming of this can be tricky. Okay, now I'll tell you an easy way to remember the name, or there's a logic to naming this kind of compound. As you can see that this is a salt, that means this is an ionic compound. Okay, remember that when we are discussing this. So this is ethane, right? If you replace one of the hydrogens of ethane with oxygen, it becomes ethoxy because there's an oxygen in place of hydrogen. Okay, so ethoxy. Now in grade 9 you have studied that the anions take the suffix "ide", "ite" or "ate". Okay, so here if this ethoxy gains a negative charge, it becomes ethoxide, right? And if you add a sodium atom next to it, okay, sodium ion next to it, it becomes sodium ethoxide, because that is how we name the ionic compounds. Metal first, followed by the anion, okay, cation followed by the anion, right? So this is your sodium ethoxide. Okay, if you had, let's say, this, what would that be? This is made from propane, so propoxide, and there's a sodium atom here, so sodium propoxide. Okay, now let's talk about the second reaction of ethanol. Its reaction with concentrated sulfuric acid. Now, for simplicity's sake, I have written ethanol in this way. Okay, I have shown one CH bond and one COH bond, right? Because when we treat ethanol, or basically any alcohol, with hot concentrated sulfuric acid, water is removed. Okay, OH from this carbon will go and H from the adjacent carbon will go. Okay, so what you will get? CH2, CH2. But is the valency of carbon satisfied? No. Two hydrogens, that means two bonds with hydrogen, one bond with this carbon, so three bonds. But carbon makes four bonds, so that means a double bond has to be introduced. Okay, so this is how you convert alcohol to alkene. Okay, this is since water is removed, this is also called as dehydration. And concentrated sulfuric acid, which is bringing about this reaction, is called as dehydrating agent. Okay, so that's all about reactions of alcohol. We have done reaction of alcohol with sodium metal and reaction of alcohol with concentrated sulfuric acid. Next we talk about dehydrogenation. Next we will talk about esterification. Okay, now let's talk about reactions of ethanoic acid, or in other words, reaction of acetic acid. The first reaction is esterification. Here, your ethanoic acid combines with ethanol. Okay, this is how you usually write ethanoic acid, and this is how you usually write ethanol. But I suggest, to be able to write the product without any mistakes, you just write acid like this, show the C double bond O, and also flip the alcohol. This is basically this thing flipped. Okay, why are we doing this? Because we have to remove water. Okay, so we are keeping the two OHs in front of each other. Now, you can remove water any way you like, as in you can remove this OH and this H, or this OH and this H. It will give you the same product. Okay, this reaction happens in presence of acid. Few drops of concentrated sulfuric acid is required to bring about this reaction. So let's remove this OH and this H. Like I said, you can remove this OH and this H also, any way you like. Now, what do we get? CH3, C double bond O, O, CH2, CH3. Okay, this is your product, plus water, of course. Okay, so these are your two products. Remember that for esterification, you have to take alcohol and acid okay, carboxylic acid and alcohol, and keep their OHs in front of each other and then just remove water. That means H2O. You have to remove that and then write the whole product as it is. Now, it's called esterification because the product that is produced is ester. Sometimes what happens is, it comes for writing the formula, not formula, functional group as this. Okay, this general formula or general way of writing ester would be given and you would have to identify the functional group. So, ester is any alkyl group, then C double bond O, then O, and then any other alkyl group or the same alkyl group, doesn't matter. Okay, so this is the general way in which we represent an ester. Okay, now there are, important thing is that esters have fruity smell. Okay, and therefore they are used in perfumes and flavoring agents, right? Now let's talk about the two activities. The first activity is you have to tell the color of pH paper in case of two acids. You have dilute HCl and then you have dilute acetic acid. You have to treat pH paper with these two acids and then you have to tell the color. Now we know that these two are acids, so they are obviously going to turn the litmus paper towards the shades of red. But acetic acid is an organic acid, and any organic acid, be it ethanoic acid, propanoic acid, butanoic acid, benzoic acid, any acid is a weak acid. So the color of any organic acid is a weak acid. Any carbon-based acid, even carbonic acid, CH2CO3, even that is a weak acid. So any carbon-based acid is a weak acid. So the color of the pH paper would turn orangish yellow or yellowish orange. Okay. With dilute HCl, HNO3, H2SO4, they are called as mineral acids. Mineral acids are strong acids. Okay, they would turn the color of pH paper to red. Okay, now the next activity is about esterification. So what happens is, you take a test tube and you add alcohol to it. Then you add glacial acetic to it. You take the mixture in a test tube. You put that in water bath. We call it water bath simply because it has water. Okay, and then you heat it on Bunsen burner and add a few drops of concentrated sulfuric acid also, because that just accelerates the reaction. Here this is the mixture of acid, that is your organic acid, and alcohol. So we are heating the mixture of carboxylic acid and alcohol in water bath because organic compounds are usually flammable. So we cannot risk them heating. We cannot risk heating them directly. Okay, that is why we heat them in water bath. Okay, indirectly. So when you do this, after some time, around after 5 minutes, if you smell the test tube, you would get a fruity smell, and fruity smell would indicate that ester is formed. Okay, so this is your activity 4.8. Now we will talk about saponification. Right, let's now talk about saponification. Saponification is the opposite of esterification. Esterification. In esterification, acid and alcohol combine to form ester. In saponification, ester is broken by the action of acid or base into acid, that is carboxylic acid, and alcohol. Okay, so basically it's just opposite of saponification. So what happens is, if you use acid, what will happen? This is the ester bond. This C single bond O is the ester bond. This will break. Okay, obviously we are using aqueous acid or aqueous base. So that means it has a lot of water. Okay, so what will happen? This bond will break. The H of the water joins with this oxygen and the OH of the water joins with this carbon. So what you get is CH3, C double bond O, OH plus CH3, CH2, OH. So that is your acid, that means carboxylic acid plus alcohol. Okay, so basically you got the same products which made the ester. Okay, now if you treat ester with base, what happens is same thing happens. First carboxylic acid and alcohol are made, and then the carboxylic acid would join with the sodium and will form this and water. So basically a simple exchange of sodium with hydrogen happens and water is released. Okay, so this is called as sodium ethanoate or sodium acetate. Okay, now this is also an ionic compound. This is also a salt. Salt basically means ionic compound. Okay, so see what's happening here. We know that NaOH is base. So something is combining with a base to give a salt and water. So that something has to be an acid. Okay, so this is basically a neutralization reaction. So any carboxylic acid, it being an acid, when reacts with base, gives you sodium salt of that acid and water. Now, talking about the name, how to name this. Now, if you see, this is ethanoic acid, right? This is ethanoic acid. If you remove hydrogen and if you put a negative charge on it, it becomes ethanoate. How? We studied in grade 9 that anions take the suffix "ide" or "ite" or "ate." So ethanoic acid becomes ethanoate as soon as it becomes an anion, right? Now if you put sodium next to it, it becomes sodium ethanoate. Okay. This is also called as sodium acetate. Acetic acid being its common name. So if this is acetic acid, the anion of acetic acid would be acetate ion. When you put a sodium next to it, that would become sodium acetate. Okay, I hope this naming helps. Now we'll talk about other reactions of ethanoic acid. Reactions of ethanoic acid with carbonates and bicarbonates or carbonates and hydrogen carbonates. Again, this reaction you have done before. Carbonates or hydrogen carbonates, whenever they react with acid, any acid, mineral acid or carbon-based acid, they would always liberate carbon dioxide, water, and a salt. Now, how would you form the salt? This is the acid. Replace hydrogen with sodium. That would be the sodium salt of that acid. Okay, naming we have just done. This is sodium acetate or sodium ethanoate, and then water and carbon dioxide would be released. But whenever you have carbonates and hydrogen carbonates, be sure that carbon dioxide would always be released. Okay, no confusion there, no special cases there. Carbon dioxide would always be released upon reaction of carbonates and hydrogen carbonates with acids, any acids. Okay, so same here. You would get sodium salt of the acid plus carbon dioxide plus water. Now, activity 4.9 talks about sodium carbonate, which is a solid. You have to take a spatula full of sodium carbonate and you have to add that in ethanoic acid. As soon as you do that, you would see a fizz. That fizz would be of carbon dioxide. Okay, a fizz would be released and that is carbon dioxide. Now, how else would you confirm that it's carbon dioxide? A test for carbon dioxide is that when you allow carbon dioxide to pass through freshly prepared lime water, it turns milky. Why does it turn milky? Because carbon dioxide, when combines with lime water, it forms calcium carbonate and water. Now this calcium carbonate is insoluble. It's insoluble. That means as soon as it's formed, it's a sort of precipitate. But the thing is, it's not a very heavy precipitate. It's a very light precipitate, low density precipitate. So it would not settle down like other precipitates. It would remain suspended. When it remains suspended, it would give the appearance of milkiness. It's a white, insoluble solid, okay, which does not settle down, remains suspended. Therefore, it gives the appearance of milkiness. Okay, now if you keep on adding carbon dioxide, so see, when you passed carbon dioxide to a clear solution of lime water, these two formed. But if you still keep on passing carbon dioxide, what will happen? So now your test tube has calcium carbonate, which is basically milkiness, and water, nothing else. But if you keep on passing carbon dioxide, what will you get? You will get calcium hydrogen carbonate. Now, calcium hydrogen carbonate is soluble. it's soluble. So that means when milkiness combined with carbon dioxide or calcium carbonate combined with carbon dioxide, it got consumed and produced something which is soluble. Soluble means you will not see any precipitates then, and precipitates got consumed. So the milkiness disappears. Milkiness disappears when you keep on passing carbon dioxide. Okay, now these are all the reactions of carbon and its compound, all 10 reactions along with their activities. Okay, I hope this helped. If you have any other doubts or any other topic that you want me to take up, please let me know in the comments. And please like, subscribe and share. Thank you for watching.